Hello, everybody. Welcome to the webinar proper, our second week of the Blockchain Fundamentals course with Dr. Rich Lane. Hello to everybody joining us from all around the world. So good morning, afternoon, evening, good night, etc. We will be having, as I said, our second of the four webinars in our Blockchain Fundamentals series. You can find the previous recordings on the Moodle, the learn.itmasters.edu.au is where you can access last week's recordings, this week's recordings in about 24 hours after we finish this session tonight, as well as quizzes, links, other course materials, etc., and the discussions with your fellow participants. So that is learn.itmasters.edu.au. My name is Jack Stewart. I'll just be moderating tonight. And we're also joined by Lily Nguyen, who is making sure everything runs technically smoothly in the back end. So we also are coming to you tonight from, in my case, from the Wurundjeri land of the Kulin Nation, from the land of the Wurundjeri people of the Eastern Kulin Nation, and from the Gadigal people of the Eora Nation, and we pay our respects to their elders past and present, as well as acknowledging the ongoing lines of culture and knowledge passed down and ongoing sovereignty. So as we begin our actual webinar, just a couple of little housekeeping things. So as we've mentioned in the past, if you can keep, please do put your questions for Rich about the course content into the Q&A section. So that is where direct questions for Rich about the content that we're covering tonight can be directed. We'll have a couple of small Q&A sessions during the webinar tonight. If your question is not able to be answered, unfortunately, we're not able to answer everyone's questions for time reasons. You can direct it to the forums at learn.itmasters.edu.au. We can discuss it with your fellow panelists, your fellow participants, as well as Rich over the next week. That's also where you can find your recordings and course materials as well. If you are interested in following up this short course with a full-length accreditation, whether that is a graduate certificate or a master's degree with IT Masters and Charles Sturt University, we have a couple of intakes that are opening up for a variety of degrees. You can have a look at the eligibility section of our website. It's a really fantastic opportunity to complete 3 short courses and gain a course credit, so 1 subject worth of credit towards one of those degrees as well. And we have our wonderful eligibility staff and Lily standing by who are able to let you know how you can access that information and also to chat to you about different pathways that you might have available to you if you would like to do further study in this area. As I said, yes, we will have the chat section is for comments and adding some kind of input and things like that. The Q&A is for direct questions about the course content. Look forward to hearing everything that Rich has to say, as well as the kinds of questions that you all have to engage in the content. And with that, I suppose we'll start the webinar with Rich now. So here's Dr. Rich Lane again. Thanks.
Thank you. Hello, everyone. Coming to you from Sydney. Got a little bit of a sore throat this week, so if I mute the microphone, it's not because I don't want to talk to you, it's because I'm probably coughing. So apologies for that. Just a quick introduction. Currently the Chief Technology Officer of a company called One Orange Cow. I currently hold a doctorate DBA from California Southern University. I did my MBA with the great people of Charles Sturt University and obviously IT Masters. I'm currently a casual academic at a different university in Sydney. I also do the president of the Doctoral Student Association of a couple of universities. In terms of blockchain, I got 3 blockchain patents. So hopefully we can impart some information regarding blockchain, and let everyone know that it's not just crypto. So I'm going to quickly cover, oops, there we go. What this course is about. These are similar slides to last week. Just recapping really quickly, the course is going to be an introduction to blockchain technology. We're not necessarily going to be talking much about crypto. We're not going to try to sell you crypto, but obviously blockchain, one of its first use was Bitcoin, which is a cryptocurrency. So we can't really not talk about it, but we're going to cover other topics such as hashing, consensus, transaction security. And what I said last week is what we're trying to do is aim that if someone said to you at a birthday party, at a Christmas party, what is blockchain? How does that actually work? You may be able to answer that question. So who's going to get value from this course? People that seek to understand further information about blockchain, business leaders looking to explore blockchain's personal potential, obviously general learners, and some knowledge of, if you have some knowledge of blockchain or cryptocurrency. I'm going to go through this quickly just because we did cover it in week 1. So just to recap, we did cover very generally what is blockchain, why blockchain, what problems does it aim to solve, some early concepts of how blockchain got to be what it is, and the fundamental, I guess, breakthroughs that had to happen in order for Bitcoin as its first use case to be invented. This week, we're going to do a deep dive into hashing, data integrity, and immutability, how that works. It's a very interesting topic. Hopefully, I've broken it down to it's not too technical, but it might be just, I think it's a good balance. I've got some demos this week that I'd love you guys to take away and try and do for yourself. We're going to talk about digital signatures, how they work. We're going to actually break down what are blocks, what are chains, why is blockchain called blockchain? And we've got some very good diagrams for that. We're going to look quickly back at the consensus mechanisms. We did talk about what consensus does last week, but we're going to look at proof of work, which is, everyone's heard of proof of work, I'm sure. If you're into cryptocurrency, you know that proof of work is what uses all the power in the world when they're doing mining, if you ever hear that example. And proof of stake, how it does quite the opposite, and their roles in validating transactions in this case. And then we're going to have a brief comparison, trade-offs and examples of the different types of consensus. Week 3, we're going to look at public versus private blockchains. Obviously there's, and I said this last time, there's purists that will basically say if it's not a public blockchain, it's not blockchain, but we will look into that because there are different types, and how some of it can be hybrid. We're going to look at smart contracts. You may have heard that used in certain cases, and what they are and what they can do. We're going to look at data storage off-chain versus on-chain, on-chain obviously being on the blockchain, and how you can actually link to external things from the blockchain that's not necessarily on the blockchain. And then integrating into business systems APIs. The final week, we're going to get really technical. We're going to look at zero-knowledge proofs. We're going to look at security considerations. We're going to look at interoperability between different blockchain systems. And we're going to wrap it up with a summary, key challenges, opportunities, that where blockchain is heading, what it's doing, and then what are the learning pathways and resources that are valid and up and coming for blockchain. So getting straight into this week's content, we're going to be looking at hashing. This is sometimes called hashing or checksum. It's sometimes called digital signature, which may not be correct, but it's also called checksums in some instances. It's used for different ways, but what it is it takes an input and turns it into what's, in this case, in this diagram, they're calling it a hash sum. And it's a fixed length number of letters and alphabet and numbers, I should say. And it, depending on the type of hash, will depend on the length. Now, if we just change one little thing within that sentence, if we even add a space after the word fox, that entire hash sum will be totally different. So if you think about that in reverse, it can be used to identify something without revealing what the actual input is. So if you wanted to put a hash sum on something that you wanted to make sure was not going to be changed, and without revealing the actual content of it, you could create a hash of that. And if any part of that changed, it would be a different hash. So you could always prove that, for example, if you've written a book, you did a hash of it, you could prove that nothing had been changed. And you could also prove at a certain point, because you'd have a timestamp potentially, if you emailed it to yourself, for example, that at this time, this text existed in this form because there's a hash sum, and it would always be the same. So I've included some common hashing algorithms. MD5 is probably well known around the world, but it's not insecure. It's insecure at this point. It used to be quite popular, but it was found to be insecure, meaning in certain cases, it wasn't actually a unique number. So new hashing algorithms have come out, SH1, SH256, and SH3. They are called sometimes SH2, 256, but generally they're the same thing. And I'm saying that just in general terms. And SHA-256 is widely used in most blockchain systems. It's used in Bitcoin. And it's a system that has been around for, I would say, I actually don't know when it came out, but it's been around for a while. All hashes generally have a lifetime, and that's for two reasons. One, they may have vulnerabilities that are found, but also just the nature of computing, it gets faster every year, more powerful. And to take an example, when internet browsers first came out and HTTP first came out, they used, I think it was 56-bit MD5 algorithms hashing to do the encrypted keys. And now that's just not really enough. You could rent an AWS server with enough power, enough money to be able to encrypt that, to decrypt that. So the length of the bits has increased, and the type of algorithm has increased to create more security. Excuse me. So again, with the common hashing algorithms, what I've done here is I've taken a string and I've written an IT master's short course on blockchain, and I've put it through an hashing algorithm, a one-way hash, and I've calculated the hash output for that string based on MD5, SH1, 256, and 3. And you can see that they're all quite different, but they're all representing the same string, the same information. So if you were to email that hash to someone, they could not reverse it. They could not figure out, well, I should say, not very easily reverse it. I'm sure in the future, if someone's watching this, it might not be the case, but they could not reverse it in 2025. But you could actually prove that that was the string that you actually sent. So in order to prove that, yes, you'd have to reveal that content, but you could just say you've got proof until that point. So we've got a little demo. don't own this website. I don't have any connection to this website. But what it does is, and I'm going to click on it. This is the website that's loaded in my browser. And we're going to put in, I'm going to take maybe this string here. Let's try hashing. I'm going to just copy that and put it into the input. So I'm going to get rid of the extra carriage return there. And what I encourage you to do is, obviously when you get these slides and you've looked at it, to come over here, and we're going to drag into the recipe, generate all hashes. And I didn't have to click bake, but it's now calculated all in the output, different hashing for this string. And I want to even show you that if you see that character there, that's actually a Unicode abbreviation. So if I change that, and I'm just going to sort of copy this so that we have it. So MD2 is 24. If I change this, so it's no longer 24. And I'm on the wrong keyboard. Oh, wait, let's change that again. There we go. So even though it looks exactly the same, it's using a different character, so that's not Unicode. And obviously, if I remove the exclamation mark, it's a totally different thing. If I add a space, it's a totally different thing. So what that means is that you can prove that this exists. And why this is important is it'll become apparent when we have a look at Bitcoin. I also want to show you one more thing, which is, for example, if you can also hash, for example, a database, or you could hash the previous block in a blockchain. You don't necessarily have to have text or a string. You could hash a piece of art that you did, or a file, or something you've downloaded. So what I'm going to do is I'm going to upload the CSU logo. Actually, it's the IT Masters logo. I apologize. And you can see, don't worry about that, but you can see the file details. And it's actually created a hash of that image. And this is how you can prove if you downloaded a file. You may have seen, for example, if you download a Linux distribution, it might come with what's called a checksum. And a checksum is just a string that's validating that the zip or the file that you're downloading has not been tampered with. So it's a way to determine that the file doesn't have malware or hasn't been modified in any way. And you could download that file, you could upload it to something like this and verify that the checksum or the hash that the website is saying matches. So apologies, I had to cough. So what does this look like? So hashing on a blockchain, what actually a blockchain does is it hashes the previous block behind it, and it stores that block within the current block that it's creating. And what I've done is I've done hashing on the blockchain, and I've got an example of looking at another site. This is an example of Blockchain Explorer. I'm just going to resize that. And I've looked at all the blocks, and I've actually gone to the Genesis block. So this is the actual first block on this Blockchain Explorer that can show the first transaction that was created. And we were talking about this last week as well. You can actually see the hash. Now, this is not the hash of the previous block, obviously, because it's the first block. So hash number 2, I'm not actually sure what that hash is, but it's clearly not the hash of the previous block, is it? But you can also see, as we discussed last week, using messaging in Bitcoin, you can actually see a message here from Satoshi, the original creator. So you can see that he was just warning people um, about banking chaos. I don't want to speculate, but you can see that was the first block and the first use of a message that's been put into a blockchain. Now, if you look at hashing, if we look at some of these hashes, you could actually fit this hash within the character limit here. So you can actually store a hash that represents something, for example, offline, such as a large database, as an image, or anything like that, and point to that in the blockchain and say, well, that's my proof, because that verifies that this database has not been changed, this file structure has not changed. So it's a very good way to link what's called a hash and put a secondary hash within the blockchain. So as discussed, hashing, what does this all mean? So we can prove something existed at a particular time, and we can do that because every block is timestamped. So obviously plus or minus however long it takes to do the transaction. But you could pretty much say that this piece of content, this artwork, this database existed at this time in this state, and you can prove it was not altered or changed. And you can prove that without revealing the data. So if you, say, for example, said, I've just invented something, but I don't want to show you yet, but I can prove it. I will show you in 2 months. And I've got an example here. For example, you create an invention or idea, but not ready to show the world. Maybe you are going to patent it or patent it, but you don't want to reveal that information. You could compute a hash, in this case, maybe a 256 hash of the document, store it and then store that hash on the public blockchain. Later, if someone comes along and says, well, no, I actually created this, or I did that, you could reveal the original at that point and prove that you had created it maybe months earlier. And you could prove that the original content had not changed since then. So it's actually a very interesting way to prove several different things at once by putting it in a public blockchain. So hashing and blockchain, how this works, it's I've got a very good photo here. I'm going to use my mouse, hopefully you can see it. You can see the blocks here, but let's just imagine these are blocks, and this is a zoomed in version of the information that's in a block. They are connected via this chain, which is a hash of the value of the pre-block or the block before it. So these are new blocks going from left to right, and this is the hash of this block here. So that similar number, it's a SHA 256, and that hash would be in there. So each block contains the data, the transactions, plus the hash of the previous block. It has a fixed length data set into it as what we call a fixed length fingerprint. If anything changes, even a space, the hash will completely change. So if anyone tampered with a block 3 blocks ago, the hash would not be valid and the chain would break. If the chain breaks, there's a problem. And if that was done on a particular node or a miner on, in this case, the blockchain network, they would then push that miner off the blockchain and say, well, you're doing something that is not correct, the consensus says you're wrong. So that's not going to be put into the public chain. So uh, uh, here we've got the breakdown of what's actually within the header of a blockchain. This is getting a bit technical. At least in 2025, this might change. Who knows? Blockchain version 3 might come out. So in the header, we have the timestamp. We have what's called a number used once, which is actually the puzzle that each miners are trying to guess. We have the version of the blockchain. I think at this point, there's two versions of blockchain in terms of protocol. The Merkle root, the difficulty, which is the hash difficulty, sorry, the difficulty to do the puzzle, and the previous hash, obviously. Underneath that, or within the same block, we have the transactions that are part of the block itself. So this is our mid break. We're actually right on 30 minutes. So if we do have some questions, I'd love to hear them.
Yes, we have a couple. Vit has asked, can blockchain potentially be editable? My understanding is that it can't, but I have seen articles previously that there was a prototype editable blockchain. So I suppose that is the question. And do you see any possibility of an editable blockchain, or does that kind of defeat the purpose or a core sort of tenet of what it is?
So purists will say it's not blockchain if you can edit it, but I also have seen that, but I don't know if that's blockchain. If you can edit it, it doesn't seem like blockchain to me. In saying that, everyone asks, well, how do you change it if you can't edit it? Well, you do what banks do, and banks, they don't reverse transaction. They when they reverse a transaction, they don't edit the previous transaction. They do a reversal of it. So if you're wanting to change something within a blockchain, you would put something in the blockchain that says, this is an amendment to this previous blockchain, and have, for example, an application that could understand that. So you'd have to obviously have a specific protocol, app that understood what a change looked like within a blockchain, but that's how you do it. You'd want that for just to have the transaction history. If there was a change, you'd want to know about it. Now, in saying that, I know there's been security issues in early blockchains where they've actually, what they've called fork or reverse a blockchain. They've gone and said, okay, this is a big problem. We're going to go back 2 days. And that's actually happened on several blockchains, for right or wrong. But to answer the question, no, I wouldn't consider it editable.
Right, that's really interesting. Bijal has asked, who audits or verifies the validity of nodes and how often?
Well, again, it depends on the blockchain. To run a node, you just have to run the software. So as long as you're running the official software and producing valid results for the network, you'll be accepted. And the software itself has got that baked in to allow that. So yeah, it's not that difficult to do, as long as you're participating with the right rules and in the right way. Yeah, it self-validates.
Great, thank you. We have a couple of questions. Let me have a look. So Don has asked, is Merkle root effectively a compounding of all prior hashes?
I'll have to get back to you on that one. The answer is no. The Merkle root's something else. We are talking about it next week. I don't have a definition right in front of me, but no, it's not a compounding of all the previous hashes.
Right, look forward to hearing more about that next week as well. And let's have a okay, so can you elaborate on how hashing is only one way and not reversible?
Interesting, because we're just about to talk about this in the
So
next
shall we take
slide.
that as
But
a great segue?
Yeah, I'll answer it really quickly. Hashing is just a one-way thing, and you might have heard of the word encryption. We're just about to talk about public and private keys, which allows for reversing of an encrypted piece of something. So, yeah, this is just one way to validate, and encryption can be a couple of different things. But yeah,
Great.
if we want to use that as a segue, I could do that.
Fantastic. Thanks very much. We'll get back into it and we'll attend to some more of the questions at the end. Thanks, everybody.
Okay, so what are digital signatures? So this is, you may have heard of the concept of wallets, which are on Bitcoin networks, for example. When you send a transaction, and we're going to talk about this in a second, when you send a transaction to the blockchain, it goes into something called the mempool. So obviously it can't be put straight into a block because a lot of people are transacting with the network. So it goes into something called mempool, short for memory pool, and the nodes then determine from the mempool who's going to be in this transaction, who's going to be in this block, I should say. In order to do that, when you send something from a wallet, there's something called a private and a public key. So you actually send your transaction with your key, with your private key to and you don't send the key obviously, but you send the transaction signed with your key, and the public key can translate it. Sorry.
I'll
So
just take this opportunity, sorry, just while you pause, just to remind everybody that if you have questions about the content, I can see a few questions in the chat section that might be really interesting to have answered in the Q&A. So if you are interested in having your question answered by Reg in the Q&A section, please direct that to the Q&A and keep the chat for sort of like comments or discussion between one another. Thanks, everyone.
Thank you. So the mempool is, as I said, a waiting area for unconfirmed transactions. This might be where if you've ever sent money to a crypto exchange or bought, why there's a delay. Now, this is just one mechanism. There are a lot of other mechanisms that other blockchain uses, but fundamentally it's very, very similar. Each node or miner keeps their own copy of the mempool, and the miners select from the mempool to include the transactions within the block. They usually pick the ones with the highest fees. You can actually specify, again, in blockchain's case, that I will pay a higher fee for my transaction to be included quicker or be approved quicker. So each wallet in this case generates a key pair. You have a private key, which is secret, and you shouldn't tell anyone. If that key gets stolen, lost, shown to someone, you've lost your Bitcoin, you've lost your cryptocurrency, you've lost your data, depending on how the wallet's used. So that's the key to the lock. The public share is used to verify the signatures. So it basically can verify that you sent that and look at the information. So I've done a simple analogy. A public key is your username, which may be your email address. It's quite known, but no one would know your password because you know that's to be kept secret. So digital signatures are used for wallets. Wallets on the blockchain network, or in this case, the Bitcoin network, stores your private keys securely. It's never shared. Creates a transaction when you send Bitcoin in this case. It uses a different, and I've written the definition, elliptical curve digital signature algorithm to sign the transactions, but we won't go into that this week. It broadcasts the signed transactions to the Bitcoin network and goes into the mempool as I've discussed. So miners nodes proof of X. And this is where we're going to start to talk about proof of work and proof of stake, and how they operate. So why would we want to operate a miner, or why would we want to create a computer that is contributing to a blockchain network? Well, blockchains operate without central authority, so they need that system that everyone can trust. So what miners do is they validate transactions, they ensure the sender has, in this case, funds from a wallet. They prevent what's called double spending, which means you do have that in your wallet. And I'm sure people are now saying questions about 51% tax, but just for the nature of this topic, they do prevent that. And they check the digital signatures for authenticity. They also add new blocks by grouping transactions together from the mempool. They mostly keep nodes in sync. They've got internal mechanisms to do that. And they maintain the correct chain order because they all have the same copy of it. So they keep the network secure, prevent malicious actors from rewriting history, make attacks like 51 economically or technically infeasible. So to take an example, the more decentralization you have, the more difficult it is. So if you wanted to own 51%, and I might talk about this really quickly because I've talked about it quite a lot. If you can control 51% of all the computers on a Bitcoin network or a blockchain network, you can control the consensus. You can control what is true and what is false. So you can actually double spend. You can say, well, no, that wasn't actually spent, or you can create invalid transactions. So it's very important to create a system that rewards honest participation. And basically, so the question I've put here is, how do we reward these people or entities for running nodes and keeping the network secure? And we use consensus mechanisms like proof of work and proof of stake, offering financial rewards, in this case for Bitcoin or Ethereum, to honest participants. So if you wanted to attack the Bitcoin network, you would need a lot of computing power in probably an impossible amount. And I say that in 2025, it might not be impossible in 5 years if you're looking at this video in 5 years, but at least now it's economically impossible. So what is proof of work? Proof of work is one of the consensus mechanisms where participants and miners compete to solve a mathematical problem. It's really just a trial and error question. But the first to solve it earns the right to generate the next block. So what that means is the miners are competing against each other and they've collected transactions from the mempool. And if they were the computer that guesses the correct number, it's like a lotto. They earn a reward. I won't go into all that this week. And they are allowed to add a block to the blockchain that becomes the next block in the blockchain. So the key concepts, the work. So why is it called work? It involves guessing or countless guesses to find a valid block hash. The puzzle's hard to solve but easy to verify. Only the fastest miner gets to add the block. So it's a race to see who can solve it the first. It's not necessarily the fastest computer, but you've got more of a chance if you've got the fastest mining equipment or the fastest set of computers. And when this first started, you could do it on your local desktop, but now you need very dedicated, specially built chip computers and mining equipment to do it. And that's where the problem comes, is that, well, Bitcoin, or even people say blockchain is very bad for the environment. Well, proof of work is probably not the most economical, environmentally friendly in terms of power use blockchain consensus method. There's obviously countries where They're using geothermal, obviously solar. China has quite a few, maybe not now, they've changed the rules, but they were using hydroelectric to reduce the cost, which makes it a little bit more economical. Excuse me, environmentally friendly. So the other one I want to talk about is what's called proof of stake. Proof of stake is a way to say we're going to put up some money, and if we, or we're going to put up some cryptocurrency, we're going to put up some Ethereum. There's a couple different examples. And if we are a bad actor or we don't play by the rules, you can take our money. So it's kind of like a deposit. And the more you put up, the more you have to risk, but the more reward that you get. So a miner, in this case using proof of stake, is they stake a bit of money or a bit of cryptocurrency and say, I'm going to be honest, and they're rewarded for doing that. So this involves no mining or energy intensive puzzles. So it's much more economical, I should say. You still need to run the nodes, but they're not sitting there crunching puzzles, or you need to have a really large computer to do it. And they verify transactions exactly the same way as proof of work. So validators can earn rewards and fees for honest behavior. If they try to cheat, their stake can be slashed or partially destroyed, or more partially destroyed, I should say. It's more scalable and aligns with economic incentives with network security. So you don't need a massive amount of massive data center to run this. You can actually run it in your house if you wanted to, off a local internet connection. So why do we need proof in blockchain? Blockchains are decentralized. There's no central authority. So the proof is the consensus mechanism, and what that does is we need to make people that participate on the network, if they're going to cheat, it's too expensive for them to cheat, or it's too risky because they're losing staked cryptocurrency. So it forces participants to follow the rules or lose their investment or the opportunity. So if they're going to put a whole bunch of money into mining equipment and not play by the rules, they're not going to win. So they'll be punished for doing that. I've got some trade-offs. So the proof of work advantages, it's obviously a proven security model. It's been around for a while. I would say at this point, proof of stake is is probably proven as well. But I didn't put it there because there was a big question mark around it when Ethereum was moving over. A lot of people were worried about it. In fact, it dipped quite a bit before that. And granted, they didn't have any problems. They were very good at doing the handover, but there was a bit of a risk potentially. And in 2025, it's very hard to attack without massive energy and hardware investments. So that's one good point. So some disadvantages for proof of work: high energy consumption. In 2025, it's expensive to participate. You need special mining equipment. It's slower somewhat, and obviously it depends on the blockchain. It's very less environmentally friendly. And it's obviously we've got Bitcoin and Litecoin as two examples. So proof of stake, it's much more energy efficient. There's no mining involved in terms of the traditional mining of proof of work. There's an easier participation. You just say, well, I'm going to stake a certain amount of coin. I'm going to put this amount of coin out there and I'm going to play by the rules. And because you're doing that, you actually can receive rewards in terms of rewards on that particular network. It has potential for faster block times. I wrote potential because it doesn't need the resources that a proof of work might need. Now, in saying that, there are different blockchains which use different systems. So I've just said that as a general statement. And it's obviously eco-friendly, mobile compatible even. The disadvantages is a proof of stake. Really, the rich get richer. If you've got a lot of Ethereum and you put it up to stake, you've got a bigger chance of getting it. But in the flip side, it's the same deal. If you're in proof of work and you want to actually try to make a business, you need to invest in a lot of hardware. So in that case, it's very similar in that case. But anyway, it's somewhat centralized because, and this is just for Ethereum, there's quite a few large stakers within some of the blockchains, and that can be a problem. And it's somewhat centralized, but I won't go into that because some people will disagree. So they've also got some strong slashing and governance mechanisms to prevent bad behavior. There's some examples are Ethereum, Solana. Apologize, I'm really suffering. So we're gonna leave some time for some questions at the end, but just wrapping up, we've explored how hashing ensures data integrity, enables immutability on the blockchain, and I've repeated that apparently because it was so important. So how private keys create signatures to prove authenticity, how transactions are grouped into blocks, and you should know now why it's called blockchain, how hashing is incorporated in order to keep that chain, and what happens when that hash breaks, because the chain would break. And we've talked about proof of work really quickly, proof of stake, how blockchain stays secure and centralized, and a little bit of a trade-off. Next week, we're going to dig deeper again. We're going to look at private versus public, smart contracts, data storage, difference off and on chain, and then some examples using APIs, some middleware, and how you can put legacy systems on the blockchain if you so wish. Questions?
Yes, we have quite a number of questions. I'll start with some of the more recent ones. Ashok has asked if Bitcoin can be reconsidered to utilize proof of stake instead of traditionally applied proof of work mechanisms, considering the environmental benefits. I suppose you covered that a little bit recently, but yeah, is there anything else that you would like to say about utilizing proof of stake instead of proof of work?
So yes, it could be done, and it was done for Ethereum. I don't know about Bitcoin because there's too much people invested in that in terms of mining equipment. So I don't know the answer to that. It's up to them, but technically, yes, it could be done.
Great. Bijal has asked, referring to the example you mentioned where someone can hash their invention and put it in a public blockchain, how does one find public blockchains available to utilize in this manner? And what does it take to sign up for a public blockchain?
Public blockchain is any blockchain like Bitcoin or Ethereum. So you can you don't have to sign up to them. You just have to participate. So yeah, it's not that difficult to find. I mean, you could easily do that. Yeah.
Right. Okay. We've got a question. Don Tibbetts, always with fantastic questions, would like to know if you think that a sufficiently motivated and resource actor, say a nation state, could possibly one day achieve the 51% milestone, and how would that impact the future of blockchain?
So anything's possible. That's why the more nodes you have, the more distributed you have, the more difficult it is. There are examples where smaller chains that has actually happened, and significant money has been lost. So if you have, and I think there was an example for a video game that was using blockchain as the currency, and that they had their own, I can't remember the name of it. They had their own cryptocurrency, and it was worth quite a bit of money, but they only had, I think, 6 nodes on their blockchain network. 4 of them were compromised. So if you can compromise in terms of they were hacked, not the network itself, but the computers that were running on, and if you can compromise 4 out of the 6, you can reverse transactions, you can control transactions, you can steal money. So um, a motivated actor, yes, 100%. State, a country that has enough resources, potentially, but you'd have to find the right blockchain to attack. Not endorsing any of that, by the way. But yeah, that's possible.
Right. Okay. That's interesting. We've got a question from Paul asking, is there a guarantee that hashing produces a unique result? For example, could 2 different inputs theoretically ever produce the same hash?
I'm going to say in 2025, because who knows what happens in the future? It's not possible. But in earlier, I think MD5 started to have what's called collisions, and collisions were similar numbers or very similar numbers. They also had, and I need to do some research, but yeah, MD5 found out that it became weak in the sense that you could potentially reverse it as well or find out some information. So, in answer to your question, no, I think at least if you use SHA-256, every hash will be different. I don't know what the future will state, but yeah, for now it's all different.
Right. Speaking of the future, I suppose we've actually had a couple of questions. They're coming thick and fast. We've got about 4 questions currently in there asking about the impact of quantum computing. So we've got questions about what your view is on the potential threat that quantum computing might pose to blockchain technology in the future, or how will it affect blockchain positively or negatively, or will it be able to overcome that blockchain technology, especially if the tech underpinning the blockchain is relying on inferior technology at that point?
So that was asked last week as well, but it was also asked in the forums, I guess in week two's forums, and which actually I think it was asked in week 3, but sorry, week 2, I should say. To answer the question, Satoshi in 2010 posted on the forums that if quantum computing ever became big enough, they would change the hashing, and we just talked about hashing this week, to a quantum resistant version. So the media loves to hype this up, and people that want to pump and dump crypto love to hype it up. And every 6 months, a news article comes out, and the Bitcoin price goes down because of it. But it's already been solved for, and I actually posted a link to the forum post that Satoshi himself wrote. So if you want to check that out, you can see what he wrote. But no, they've already thought about it. It's not necessarily going to be a problem, assuming they don't instantly have a quantum computing tomorrow, and the computing power of quantum computers ramps up on a steady pace. They've accounted for it.
Right. Sorry, my apologies. I have not been on the forum. So, a great reminder for everyone to check out the forums and contribute to them and have, some engagement in those discussions. I might open up just the questions to you for the rest of it, Rich. If you'd like to choose your favorites.
Sure, I have to stop my screen share to find them. So there's a question from Stephen or Stefan. Do you only need to check the hash of the last box to check the integrity of the whole chain? Yes, that's really, really important. The reason being is if you don't have to check the whole thing, you just check the previous one. And the reason you do that is because the previous one has the previous one, and the previous one before that has the previous one. That's the chain. So if any of the blockchains break, it's going to break, and going to know exactly where it broke from. So that's a really good question. So someone asked, does adding salting to hashing make it more secure? The answer is yes, but this is a different type of encryption. So if you are going to do encryption, yes, always use salt. And if you don't know what I mean, please Google it. It's very interesting. Question, is it possible to move from one blockchain to another? It's very interesting. In some blockchains, Ethereum's one example, they have what's called different layers, and I don't want to get into that this week. We're getting a bit deep. And they have something called DApps, or decentralized apps, and they're applications, and I'm going to just be really general here, that sit in different layers of different blockchains. And what they look for is what they call swaps. So you're not moving, excuse me, you're not moving something from another, but you will swap. So essentially, you could take some information from one and possibly put it into another. So let's have a look at some more questions. Is the nuance unique, or which is the number that they're trying to figure out for the mining? Good question. I've never thought about that, if it's unique. I don't know if it needs to be unique, but that's a very interesting question. So I'm going to research that. I don't see a problem if it's reused, but I've never thought about that. So that's a very good question. And so Paul actually asked, is the hash of the first block a hash of itself? Well, you can't hash yourself, can you? You can't have something and then hash it. So you need to have it and then hash it. So I guess homework for me is to find out what the hash is of, or homework for you. I'd be very interested if anyone would like to post that on the forums. What is the hash that is in the Genesis block of Bitcoin? There's a question from Don. Could the mempool be compromised to steal or corrupt the data? Anything's possible. I don't believe it's been done, at least on Bitcoin. I'm sure there's some bad actor out there that's trying to compromise it right now as we speak, but no, I wouldn't say it's not possible, but yeah, I've not heard about it. I'm not saying that it hasn't happened. So, question: can you find out who modified the hash key? I'd say probably not. They might hide their tracks unless they were really obvious about it. You could probably determine which node it came from, how that happened, or whether it was a bad actor or the node itself. You could probably find out that about that much information, and then from then on, it would be if the person running that node wanted to reveal any information. So, I'll take one more question. So Earl asks, aside from crypto, what are some popular uses of blockchain right now? I encourage you to look at last week's video, but blockchain is obviously used for banking transfers. It's used for validation. It's used for identification purposes. It's used for voting. And I also posted last week a couple of websites. The classic example for blockchain is supply chain. And I posted up two examples of tracking from the source of diamonds. So from where it's mined all the way to where it's put onto a jewel. So the person buying it knows the provenance of where that diamond may have come from. So I encourage you to have a look at the forums for that one.
Great. All right. Thanks very much for today, Rich. Thank you everyone for participating as well. Fantastic questions, really great engagement. Hopefully everyone will also be able to continue with that engagement, especially those of you who unfortunately we weren't able to answer your questions for time reasons. You can check out our forums. You should be able to log into those with the information you received when you signed up for the short course, and that's at learn.itmasters.edu.au. So you can find all of the forums as well as the recordings from tonight and last week. This recording will be uploaded within about 24 hours from now, as well as your quizzes and additional information and things that Rich has uploaded. So definitely check out those forums for more information and further engagement. That is all for us for this week. We will see you here again same time next week. That's 7:30 p.m. Australian Eastern Standard Time, or the equivalent to you locally. Thank you once again very much to Dr. Rich Lane for a very informative and interesting session. Rich, did you have anything else that you'd like to add before we head off?
No, I just want to say thank you, and I encourage you to go to the forums. I'm answering a few of your questions, so it's great to see everyone interested.
Great. Thanks very much, everybody. Once again, please do check out IT Masters full-length courses as well, and you can check out the eligibility on the IT Masters website to see if you are eligible, if you're interested in studying a full-length graduate certificate or Masters with us in the future. Thank you, panel, very much again. Thank you, Dr. Rich. We'll see everybody, hopefully, here next week, same time, same place, and look forward to seeing you then. Thanks, everyone. Good night.